Copyrights resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Welcome to Start Academy Publishing, and this is the book Mathematics for IIT-JEE Advanced by M. Khanna sir and here we are going to discuss the problems and concepts of the book of this chapter which we are going to discuss today. So we have the chapter today which is chapter number 23 and it is volume 2 of the book and it is coordinate geometry of 3 dimensions. Right, students? Here we have few theories which we have to do, few concepts which we have to overview. So what are those concepts? Let us see. First of all, when we talk about 3D geometry, so here there is a line and there is an angle which it makes with the 3 axes x, y and z axis. So the angle which this makes with the x axis may be called alpha, with the y axis may be called beta, and with the z axis may be called gamma. So their axis is actually protruding out of this plane and it is a 3-dimensional figure which I can't draw on this plane, but this is a spatial figure. Now if you take these 3 angles, then cos alpha, cos beta, cos gamma are called the direction cosines of this line, and this cos alpha is called L, cos beta is called M and cos gamma is called N. This is the way which we denote it, and we have L square plus M square plus N square is equal to 1. This is the first result which we have to remember regarding it, and these are called the direction cosines. What are these called? Direction cosines, as alpha, beta, gamma are called the direction angles. So direction cosines are L, M, N, and alpha, beta, gamma are the direction angles. Now there is a term called direction ratios. What are direction ratios? Direction ratios of the values A, B, C. Let us take A, B, C and let us call it as direction ratios. So direction ratios are the values of A, B, C such that if you take A is to L, that it is equal to B is to M and it is equal to C is to N. So it is proportional to LMN, whereas L square plus M square plus N square has to be equal to 1, but A square plus B square plus C square can have any value. So you can say that the line L is having direction ratios and direction cosines as proportional values. Now we have few things regarding its equation. If we take a line and it is having a point on it x1 comma y1 comma z1, and we take a point x comma y comma z on this line which is a variable point, then we can say that x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. So this is actually ABC, the direction ratio of this line. We can take the direction cosine also, LMN also we can take, of course. So this is how we write the equation of a line. Now what happens when we take 2 points? Instead of direction ratios, we take 2 points x1, y1, z1 and x2, y2, z2. Then in that situation we get x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1, and x, y, z are the coordinates of any variable point on the line. Now what does it mean? It means that this x2 minus x1, y2 minus y1 and z2 minus z1 are actually the direction ratios of this line. So you can also say that if on a line 2 points are given x1, y1, z1 and x2, y2, z2, then its direction ratios are A, B, C. So A by x2 minus x1 is equal to B by y2 minus y1 and then C by z2 minus z1. So this is also what you can remember. And if it is further asked that what are the direction cosines, so can you tell what are the direction cosines? So direction cosine will be L, which will be A by root over sigma A square. What does it mean? A by A square plus B square plus C square. And then we have M, which is B by root over sigma B A square again. And then we have N, which is C by over sigma A square again. So these are the direction cosines L, M, N. Now, if you want to go into the plane, then in a plane, we have to remember that the equation of a plane is like this: AX plus BY plus CZ is equal to D. Now, what are the different terms here? Like A, B, C, which are the coefficients of X, Y, Z? So, A, B, C are actually the direction ratios of normal to the plane. So, if we have a plane like this, and we have a normal to the plane like this, which is perpendicular to the plane, then its direction ratios are A, B, C. These are the direction ratios, and this is how we can write the equation of the plane in terms of its direction ratios, and D is a constant. Now, D can also be defined. So, if we take A by root over sigma of A square plus B by root over sigma of A square plus C by root over sigma of A square, and these are the coefficients of X, Y, Z, then here d by root over sigma of A square will be there. Now these three terms are L, M, N, and here we have d by root over sigma A square. Now when we take a plane like this and we take the perpendicular distance from origin, then this distance is d by root over sigma A square. This is what geometrically this d means, that is d by root over A square plus B square plus C square. So this is what its resemblance is geometrically. Now if we are asked to find that what is the angle between two lines, so if one line is having direction ratio L by A1 B1 C1, another is having direction ratio A2 B2 C2, and we will have to find the angle between them, then cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 by root over sigma A1 square into root over sigma A2 square, like this. So this is how we find the angle between two lines. Similarly, we can find the angle between two planes by finding the angle between their normals. Now here there is a question: the ratio in which the square x square plus y square plus z square is equal to 504 divides the line joining the point 12 minus 4 8 and 27 minus 9 18 is. So let us suppose that ratio is k is to 1. So the sphere is dividing it in the ratio k is to 1. So the point on the sphere will be 12 plus 27k by k plus 1, comma, minus 4 minus 9k by k plus 1, comma, 8 plus 18k by k plus 1. So these are the points, and these points lie on the sphere. Now if these points are on the sphere, then it will satisfy the equation of the sphere. What we will say, that this satisfy this also lie on y, and this is z. So 12 plus 27k whole square plus 4 plus 9k whole square, as minus square is plus 8 plus 18k whole square is equal to 504 into k plus 1 whole square. We will write it like this. Now if we calculate, then we have 27 square plus 9 square plus 18 square. So 27 square, if we do the calculation part here, so that will be 49, 4 carry 14, 189 7 to 14, 145. So this will be 729 k square, then 81 k square. Okay. And then we have 18 square k square. So 18 square is 384 as far as I remember. So this will be like this, and 18, yeah, so 324. This will be 324. We'll add 324 to it. So we'll get 4, and then 14, 1 carry, 13, 1 carry, 11. K square plus 2AB. So 12 into 27, that you have to calculate, which will become 27 into 12, 170 plus 54, that will be 4, 12, 324 plus 9 into 4, 36, right? Then 18 into 8, that would be 144. So we will add them. So we have 14, 1 carry, 10, 1 carry, 504 into 2. So 2 into 504 into K. 2AB is the formula, plus constant square. So constant square will be 12 square 144 plus 16. That will be 160. 160 plus 64, 224. This will be 504 K square plus 504 plus 2 into 504 K. Now this 2 into 504 K will get cancelled. And what will we get is 1134 K square and 504 K square, that will become 0 and 3 and 6 K square is equal to, this will become 0 and 8 and 2. So this will be 280, right? Okay. So 280 by 630, that will be 28 by 63. So that will become, so 9, 7 is 63. So this will become 9, and 4, 7 is 28. This will become 4. So K is equal to 2 by 3. So students, we are getting K is equal to 2 by 3. That means the value of K is 2 by 3. So if we take K is to 1, so 2 is to 3 is the option, which is B option. We can take the B option. K can also be minus 2 by 3, as the value of K could be plus minus both. So we have to see that whether this point is inside and outside, what is the situation. So if we put here, it will be 144 plus 16 plus 64, which is actually less than 500. So this is a negative value, S1 is negative, so it is inside the sphere. And if you put 27 here and minus 9 here and 18 here, the value will be greater than 500, as 27 square alone is 729. So we will say that this is positive. So S1 is negative for this and positive for this. It means one point is inside the sphere, another point is outside the sphere. So this is the internal bisector. It is a section formula, which is an internal section formula. So it is 2:3, which is our answer, not -2. Prove that the angle between two diagonals of a cube is cos inverse 1 by 3. So what we can do here, we make a cube, and for simplicity, which will not lose the general situation also, we take the coordinates as x, y, z, and we have this cube, and we take this as 0, 0, 0, this point as 0, a, 0, this point as on z axis 0, 0, a, this point on yz plane, so 0, a, Then we have this point on yx plane. We can take here x, not this side, this is x dash. Let us take x in this direction. X here also you can take, no issue. I'm taking it there. So there it will be x will be a, y will be a, z is 0. This point will be a 0 0, and this point will be uh, a, and one point is remaining which is on the xz plane actually. So this will become a 0 a. So this is how we have denoted all the 8 vertices of the cube. Now if you want to find the angle between two diagonals, so let us take one point A and opposite to that this B. So cos of the angle alpha, which AB, and we can say that this is AB, so don't write like this. We can take the direction ratio of AB. So AB will have the direction ratio as A minus 0, A minus 0, A minus 0. Another diagonal would be, you can take this point and you can take this point. So this is C and this is D, like here. This point you can take diagonally opposite, and another point is this height. What will be the direction ratio now of CD? So you will say that it is A minus 0, 0 minus A, and A minus 0, like this. Now if you take the angle between them, cos alpha, so it will be A square, that is the dot product of this, that is A into A, minus A square plus A square, like this, upon root over sigma A square. So root over 3A square into root over 3A square. So this will become equal to A square by root 3 will be 3 and A will be A square. So this will be 1 by 3. A square will get cancelled. Alpha is equal to cos inverse 1 by 3. So alpha is equal to cos inverse 1 by 3. So this is what we have to prove actually here. So you have to make a correct diagram, then you have to analyze what are the diagonally opposite points, and then you can find the direction ratios of those lines, and then find the angle between them. Find the angle theta between this line and the plane. This is such that sin theta is equal to 1 by 3 is the value of lambda is. So as we know that this is 1 to 2 direction ratio of the line and 2 minus 1 root lambda direction ratio of the normal to the plane. So if this is the plane and this is normal to the plane and there is a line, this one. So the angle between normal to the plane and the line will be actually this one, and the angle and the line angle between the plane and the line will be this one. If this is theta, then this will be 90 degree minus theta, right? So we know that this is if alpha, that is the angle between the line and the normal is alpha. So cos alpha is equal to, this is 2. So 2 minus 2 plus 2 lambda, like this, upon root over 1 square plus 2 square plus 2 square, that will be 3, into root over 4 plus 1 5 plus lambda, like this. So this is cos alpha, whereas sin cos alpha is equal to sin theta, because alpha is 90 degree minus theta. So we can say sin theta is 1 by 3. So this is 1 by 3. Now let us cancel this, and we have, for cross multiplying, first let us cancel 3 also. So root over 5 plus lambda is equal to 2 root lambda. This is what we are getting here. Now we square both the sides. So we get 5 plus lambda is equal to 4 lambda. So we get lambda is equal to 5 upon 3. So if we see, then we have the option C, which is the correct option here. Now let us come to the next question. So the next question is that equation of the line of shortest between the lines, this one and this one, is this one. What we will do, we will have two lines. The point here is minus 3, 1, which is actually the direction ratio of the first line. And another line is 3 minus 5 minus 5. Points are 0, 0, 0 there. And the point here is 1 minus 3. Like this. Now, if we take the shortest distance line, then it is the common number. Where its direction ratio can be taken as AB. And the foot of the perpendicular here can be taken if suppose this is x1, y1, z1 is equal to lambda. This point can be taken as lambda minus 3 lambda from, so it will be lambda comma minus 3 lambda comma lambda. And if you talk about another foot of the perpendicular, that is of this line, then it is suppose equal to 3 mu plus 2. This is 3 mu plus 2. Then we have minus 5 mu plus 1. And then we have 2 mu minus 2. Like this. Now we have these of the perpendicular. So can we find the direction ratio ABC? ABC will be lambda minus 3 mu. So you can take 2 lambda minus 3 mu. Sorry, this is mu. And then we have minus 2 also. So 2 lambda minus 3 mu minus 2, then minus 3 lambda plus 5 mu minus 1. And then we have lambda minus 2 mu plus 2. So these are the AB, direction ratio of this common perpendicular to both the lines. Now, the dot product of this one is minus 3, 1 is 0 because the angle between them is 90 degrees. So we can take 2 into this one minus 3 into this one plus 1 into this one and 0. So what will we get? 4 lambda and then we have plus 9 lambda. 9 plus 4, 13 lambda plus lambda is 14 lambda. Then we have minus 6 mu and then we have minus 15. So minus 6 mu minus 15 minus 21 minus 2 is minus 23. Then we have constant minus 4 plus 3 minus 1 plus 2 plus 1 is equal to 0. So this is one equation. In another equation what we will take these direction ratio 3 minus 5. When you will take 3, next time you will put here 3 and here we will take minus 5 and here we will take 2 here only. This will become 6 lambda and this will become 15. Yeah, it will become 15 lambda. 6 lambda plus 15 lambda is 21 lambda. Plus 2 lambda is 23 lambda, right? And what about mu? We have minus 9 mu and minus 25 mu. So minus 34 mu and minus 4 mu. So minus 34 minus 4 minus 38. And what about the constant? Minus 6 and plus 5. That will be minus 1 plus 4 plus 3 is equal to 0. Now we have two equations from where we have to solve lambda and mu and we will get lambda and mu after solving this equation. We will solve this equation, find lambda and mu and then you will put in the place of these 2 points, right? So when you put in the place of these 2 points, you'll get the 2 points and then you have to write the 2-point form of the equation of a line that is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus. So I'm not doing that calculation part. I hope it is clear to you as there is a space constraint also, but we will do it. Now let us do the next question. Find the equation of the plane to the point minus 1, 1, 1 and 1 minus 1 1 is perpendicular to the plane x plus 5 plus 6z is equal to 7. So we have to find the equation of the plane to the points this and perpendicular to the plane this. So if plane is perpendicular to this plane, then their normal are also perpendicular. So we can take that A plus B plus 2C is equal to B. And 1 and the direction is of the normal of this plane. And let us suppose ABC is the normal of that plane which we have to find. Normal of the direction ratio of the normal of the plane which we have to find. Now we have A into x plus 1 plus B pi minus 1 plus C z minus 1 is equal to 0 as the equation of the plane. Since it is passing through this point and it is also satisfying this point, so we can substitute this point in place of x, y, z and we'll get A, and this will become minus 2p and this will become 0. So A is equal to B from. And then if A is equal to B, we get here 3p plus 2c is equal to. So we get C is equal to minus 3p by 2. So we have A as B, C as minus 3p by 2. Now we have to find the equation of the plane. So we can write A as B into x plus 1 plus B as B only y minus 1 plus C as minus 3p by 2 z minus 1 is equal to 0 like this. Now we have B common and which can be taken outside and it will divide to 0 and it will become 0. So we have x plus y minus 3 by 2z. So we can say 2x plus 2y minus 3z like this. Then we have 1 and 1 get cancelled and we have plus 3 is equal to 0. So this is what is the equation of the plane we have to find. Next, let us come to the another question. A point P on the plane by A plus y by B plus z by C is equal to 1, which is fixed. The plane is perpendicular to C leaves the axis in A, B and C. So let us suppose the point on the plane P x1, y1, z1. The plane P perpendicular to O. So if you take a plane which is path P and it is perpendicular to O, we can say that the distance from origin is actually equal to OP, which is over x1 square plus y1 square plus z1 square, right? That is the distance from origin of this plane. And if we have this distance, and what are the direction ratios? So this is x1, y1, z1 because this is the point on the plane. So the normal, axis we have to find. So the point is on this plane, which is fixed, right? The plane should be perpendicular to P means the axis AB and C. So if we take the plane P perpendicular to P, then the normal is x1 y1. So we can say x1 x plus y1 y plus z1 z and the over x1 square plus y1 over sigma of x1 square, that will be the direction to find that particular normal to the plane, and that is equal to distance from origin, that will become over x1 square plus y1 square plus z1 square, right? This is what is happening, which can be written as x1 x plus y1 y plus z1 z is equal to x1 square plus y1 square plus z1 square. So after this, it is saying that the plane passes its axis is A, B, and C. So if we talk about the point A, then its x coordinate will be x1 square plus y1 square plus z1 square by x1 and other intercepts are 0. If talk about b, then it will become 0 comma y1 by x1 square plus y1 square plus z1 square, and then it will be 0. And if you take about c, then it will be 0 comma 0 comma z1 by x1 square plus y1 square plus z1 square. So these are the 3 points A. Now the plane ABC parallel to YZ, ZX, XY planes intersect in Q. So if they intersect in Q, then Q will be actually this intercept, comma this intercept, comma this intercept. Let's say x1 by root over sigma of x1 square, comma y1 by root over sigma of y1 square, comma z1 by root over dot root, dot root cancel part. This is z1. So x1 by sigma of x1 square, comma y1 by sigma of y1 square or x1 square, whatever you say, comma z1 by sigma of x1 square or z1 square or y1 square. All are same. Sigma is same for x1 square, sigma, y1 square, sigma, z1. All are x1 square, y1 square, z1. So this is actually basic of it. You're getting here. So the point is coming this one, this one. So I'm writing it freshly. I'm not recalculating it. I hope you have seen the calculation part and the part. So this is actually now I'm saying that it is x1 square plus y1 square plus z1 square by x1 is actually alpha, and then x1 square plus y1 square plus z1 square by y1 is beta, and x1 square plus y1 square plus z1 square by z1. So we have alpha, beta, and gamma. Now if we take alpha, beta, gamma at this point, then we have to prove that it satisfies this. So let us see left hand side part. That is 1 by x square plus 1 by x square plus 1 by z. If we do this 1 by alpha square, it becomes alpha square, beta square, gamma square. So this will become x1 square by x1 square plus y1 square plus z1 square whole square. So finally it will become 1 by x1 square plus y1 square plus z1. This will be NH after you substitute alpha, beta, and gamma. And when you take the right hand side, is equal to 1 by ax. So again 1 by x is 1 by alpha, it is x1 by this by a plus y1 by b plus z1 by c by it will become x1 square plus y1 square plus z1 by. Now we know that x1 by a plus y1 by b plus z1 by c is equal to 1 because p x1 y1 z1 lies on this plane. So this is 1. So this will be 1 by x1 square plus y1 square plus z1 square. So yes, the left hand side and right hand side are actually equal. So the next question we have, if the line x equal to y equal to z, intersect the line x sin a plus y sin b plus x sin c, then b square, x sin 2a plus y sin 2b plus z sin b is equal to b square, where a plus b plus c is equal to 5. You can say that these are the angles of a triangle. Then sin a by 2, sin b by 2, sin c by 2 is equal. So first of all, since this line intersects this line, which is actually in the form of planes, so we can say that suppose they are equal to alpha, so x, y, z are all alpha. You can take it as alpha common sin A plus sin B plus sin C is equal to 2b square. And here if you take alpha common, then sin 2a plus sine 2t plus sine 2c is equal to t square. Now we know that if a plus b plus c equal to pi from trigonometry, we can write it alpha into 4 cos a by 2 cos b by 2 cos c by 2 equal to, and here we can write from trigonometry 4 sin a sin b sin c is equal to d square. Now when we will divide, what will happen? Alpha alpha will cancel, 4 will cancel, and you will get sin a sin b sin c by cos a by 2 cos b by 2 cos b by 2, and sin a can be written as 2 sin a by 2 into cos b by 2. Similarly, sin b can be written as sin b by 2 into cos b by 2, and sin c can be written as 2 sin by 2 cos c by 2 divided by cos a by 2 cos b by 2 cos c by 2 is equal to d square by 2d square, that will be half. D square will get cancelled, and then what will happen? Cos a by 2 will cancel, cos b by 2 will cancel, and cos c by 2 will cancel. Then we have sin a by 2 into sin b by 2 into sin c by 2 is equal to 1 by 60. The value is 1 by 60. Now let us come to the next question. Find the equation of the two tangent planes to the sphere which are parallel to this plane. So the direction ratio of the normal is -1, and this is the sphere. There is a plane like this and another plane like this. The sphere is having this equation. So we can take the parallel plane as 2x plus 2y minus z is equal to k limit, parallel to this. Now the distance from center, so center is g is 0 minus f. So 2f is minus 2, so minus f is 1, and z is h minus 3, so this will be 0 1 3. And then we have the perpendicular from the center on the plane, so this will be 0 plus 2 minus 3 mod of this pi minus k of pi over 4 plus 4 plus 1, that will be 3, is equal to its radius. What will be its radius? So radius is g square plus f square plus h square minus 6, so minus 5. So that will be equal to this, and this will be 5 finally. So root over this is the radius. This is root over 5. You can find 1 plus k is equal to 45. K is equal to 40. After you get the value of k, you can find the k. And another value of k can also be obtained as it is plus minus 4. So after taking mod, so what will happen? Okay, so actually it is not plus minus 45. It will be 1 plus k whole square, right, students? After taking square, so 1 plus k square plus 2k. That's what will happen. If I take k is equal to 44, it will become k square plus 2k, and one value will be plus 46 is equal to 0, and another value will be k square, only one value 45 or 5 square. So from here you can find the two values of k and you can find the equation of that. That is all for today's lecture, sir. Thank you.